let's say,
Thanks, Dakota.
Yep.
Yeah, you're welcome. Yeah, it's already too hard.
okay. That's okay. So let's say that these were the type of functions we had. Now, this is actually a quadratic function. It actually kind of looks like a U eventually. This is a linear function, this is a linear function. First of all, how do I tell what type of function it is? How did I know that? I'm a super freaking genius. That's how you know things.
Yeah, you want.
There's no real other explanation. There's just some guys who get math and they just know stuff. No one else can know it. It's not allowed. No, that isn't how it works. Okay, so these two I know are linear and this one I know is quadratic. What do you notice? What's the difference between them?
One of the x's has a second power.
Yeah, it has a square power, right? That's how I know this is going to be a quadratic. It's going to look like a U. These are to the what power? First power, so I know these are going to be linear. I'm going to show you one more that's linear. I guess I'll write it up here. And this is called a constant linear function, but that's okay. We'll show that also. All right, what we're going to do for every one of these is I want you to find f of negative 2, f of 0, f of 2, and f of, let's say, 5. Okay? I want you to find each of these values. Let's do negative 5 instead. Okay? Let's find each of those values. And let's change this one to a negative 3x, just for fun. All right. So what is this asking me to do with these?
Find x.
What's it asking me to actually do?
Find x.
No, it's not asking me to find x. X is right here. Oh, there is no x. So it's just right there. There's x, I found it. Okay, so it's not asking me to find x. What's it asking me to do? What am I supposed to do with those values? Negative 2, 0, 2, and 5. Negative 5.
Times them.
What?
Times them.
I might have to times them.
Or add them.
I might have to add them.
Divide them.
I am not going to have to divide them.
Plug them in.
I am definitely going to have to do what Logan said. Okay, say that again, Logan, really loud.
Plug them in for x.
I'm going to have to substitute them for the x values in each one of those equations. Do you have a question so far? You should.
I'm confused.
Good. Good. So think about this. He said I'm going to substitute in for the x values in each equation. What's wrong with the top equation?
There is a next value.
There isn't an x value. So where am I going to substitute it in for it?
You're just gonna times it.
I'm actually subbing it in non-existent. Let me show you what I mean by that. So really, there is a 0x here. Is that not true? What's 0 times x?
0.
What's 0 times 100?
0.
What's 0 times 5?
0.
0. What's any number that I plug in for x going to be when I add it to 5?
0.
0 plus 5 is,
5.
it's going to constantly be what? 5. In fact, I said when I first wrote that equation that it was a what type of equation? Do you remember what I said? It's a constant linear equation. It's constantly going to be what?
When
Well, no. What is the constant value going to be?
0. 5.
It's going to be 0 as I plug it in, but then it's going to be 0 plus 5, which is always going to be what?
5.
5. This is always going to be 5. So let's plug all these in. F of negative 2, think about putting it in there, what would it be? 5. F of 0, plug it in there, what will it be? 5. F of 2, plug it in there, what will it be? And f of negative 5, what will it be?
5.
Okay, now, this is what I want you to think about. How would that look on a graph? How would it look on a graph?
It'd just be like a line,
How come?
because it's just 5.
By the way, just because it's a line, well, how does that line look? That's the question.
Right?
It could go slant to the right, slant to the left, it can slant up, it can slant down, it can be vertical, it can be horizontal.
Horizontal,
How come?
because 5's going this way.
5 is going this way, where y, by the way, some people say this is the y value, which is true. I'm finding the y value. The y value is constantly what? 5. So exactly what Gannon said. Think about this. Now I can plug in any x value I want. Think about this. What values did I plug in? Negative 2. So let's go to negative 2 on the x. Notice what we're plugging in is the x value. This is the important part. What we're substituting in, these values right here are all what values? X's or y's? X's. These values are x values. That's why I'm replacing the x's in every one of these with these values.
Yeah.
Everybody understand that? These are x values. What the result is when I plug it in is the what value? The y value. That's why we call it dependent versus what? Independent. Do you remember that we talked about that? The dependent variable is the y value. It is dependent upon the independent variable what? X. X is independent. I can pick any x's I want. Could I have put negative 1 and could I have put like 5 and could I have put 100? Yeah, I could put anything I want for the x. It is independent. I can pick what I want. But the y's are going to be dependent upon what I choose for x. Okay? Now in this case, I can choose any x I want. I can choose negative 2. Where will I end up at?
5,
I can choose 0. Where will I end up at?
5,
I can choose 2. Where will I end up at?
5,
I can choose negative 5. Where will I end up at?
5,
If I chose 5, where would I end up at?
5,
If I chose 100, where would I end up at?
5,
If I chose 1, where would I end up at?
5,
What if I chose a half?
5,
Negative a half.
5,
2 3/4.
5,
5 7/8. Doesn't matter, right? I'm always going to end up at what? At 5. What type of line then do I have? What type of line is that?
a constant.
Horizontal. It's a constant line. It's a constant linear function. All constant linear functions are going to be horizontal. It's because no matter which x value you plug in, and it's really like this, you're going to get a constant value of 5. That's why we call this number that's added a what? What do we call it? Starts with a C.
Constant.
A constant, right. A constant. And that is the constant value. That's fairly easy, wasn't it? Okay, let's try this one. Okay, this one's going to be a little more difficult. So Seth, plugging in negative 2, and here's something that is very key, and I want you to write this in your notes. So open up your green notebooks or whatever, turn to section 3.3, and we're going to put this in our notes. I think it's 3.3. Am I on 3.3, Kate? So
71 is a good one to take notes on.
yeah, 71. Turn to page 71. Take some notes on this. This is one of the most important things I'm going to show you that will help you to get signs right and to make sure that when you substitute in, you do the order of operations right. And that is whenever you substitute for x, this is what I want you to write in your notes. Whenever you substitute for x, put a parenthesis around the substituted value. Whenever you substitute for x, put a parenthesis around the substituted value as you substitute. In other words, I'm going to write this as 2 and then what? A lot of kids want to put a times sign right here, okay? Because it's 2 times what? X. That's true, but I want to put it in a parenthesis instead. Does that still mean times? Yes, but the reason is, when I get to this question, where I have something squared, and I have something in front, in fact, I'm going to change this a little bit. I'm going to switch this to like a 5. No, that'll make it too big. Let's change this to a 3, just so that it's not the same as the square. Okay, so when I get to this one, I'm going to have to do an exponent and then multiply. So I don't want you to just think, when I substitute, I'm not automatically going to multiply. I want you to think, I am replacing the x, and I'll do whatever I have to operation-wise. And that's important. So as I get f of negative 2 equals this, what do I do, Seth? What do I do with 2 and negative 2 then?
Times
Times them, what does that make?
-4,
Negative 4 plus 1 is?
-3,
Negative 4 plus 1 is what?
-3.
Negative 3. Okay. And that is the what value, Seth? What is negative 3? Is it the x value or the y value?
X.
No. This is the y value. What is the x value for this point? What is the x value for this point? When x is what? That's the x value. When x is negative 2, y will be what?
All or
Negative 3. Everybody got that? I'm going to put that on my graph right now. Okay, so this was number 1. Oh, sorry, number 1. This is going to be number 2. Okay, I'm going to start at negative 2 and negative 3. Everybody agree with that point?
Yeah.
Notice the x value that I substituted in is the x coordinate. This is important. And then the value I get when I substitute it in is the what? Y coordinate. Okay, so you want to write this in your notes. When substituting, the number you substitute is the what value? X value. When substituting, the value you substitute is the what? X value. I would underline X, right? Because that's the important part. The number you substitute is the X value. The value you get after the math, after you do the math, is the what value? Is the Y value. Underline Y value. The value you get after you do the math is the Y value. That is super important because I don't want you to get mixed up X and Y values, okay? And a lot of kids do. Remember, whatever you substitute is the X value. Whatever you get is the Y value. Okay, let's do 0. So, Briley, what am I going to write? 2 what? Parenthesis and then what? Nope. What am I subbing? 0. Super important here. I see a lot of kids write negative 2x. I see a lot of kids write 0x. You're not putting it in front of the x. You're actually replacing the what? X. So if Callie's in a game, right? Basketball game, soccer game, football, whatever. It doesn't matter, right? Callie's in the game. Okay? Whatever game it is, it doesn't matter. Callie's in the game and Seth comes in as a substitute for Callie. What does Callie have to do? Leave the field of play, right? No matter what. Has to leave the field of play. And who is now in the game? Seth. Seth is in the game. Are they in the game together at the same time?
No.
No. Because Seth was the substitute for what? Callie. Same thing happens here. You can't leave the x in the equation. You've got to replace it. You've got to take the x out of the game, and you've got to put the new value in for x. Are you with me? So when I ask Briley, what should I put in for, what should I write? I'm asking, what is the substituted value for x, which is 0, right? Now I just put plus 1. The plus 1 doesn't go away. The 2 doesn't go away. The only thing that got replaced was what? Was the substitution, was the x that went in, right? 0 went in for the x. It replaced it. Everybody understand now? Okay, now what is that going to give me?
0.
Just do the math. 2 times 0 is?
0.
0 plus 1 is? 1. What is 1? Is it an x value or a y value? Y value. What is the x value?
-3.
Nope. 0. 0 is the x. 1 is the y. Everybody got it? I'm going to mark that. 0 is the x. 1 is the y. Everybody with me so far? Okay. All right. Now what? What should I replace? What do I need to replace? I need to replace a -2, I need to replace a 0, now I need to replace a what?
2.
A 2. F of 2. So, what should I write? This Logan. Logan, what should I write right here when I'm substituting in a 2? What should I write?
2 parentheses,
But the x is being replaced by what?
2.
The 2. So put the 2 in, don't put an x in. Okay, a lot of kids, like I said, they want to put 2x. Don't do that. It's a substitution. You're replacing Callie with Seth, right? So you're actually taking out the x, it's gone, and I'm replacing it with the 2. Okay? And then put plus what? Plus 1. What will I get? What's 2 times 2 plus 1?
5.
5 total, right? What does the 5 represent?
Y.
The y. What is the x?
3. Or 2.
2. Okay, it's the number I put in. So I'm going to go to 2, and then I'm going to go up what?
5.
1, 2, 3, 4, 5. Okay? What else? Plug in what? -5. So let's go f of -5. Okay? 2 times what? -5 plus what? 1. Notice the 2 and the 1 stay in there the whole time. I'm replacing the x, replacing it. Don't leave it in there, replace it with these values that are given out to the side. What do I get? What's 2 times -5? -10 plus 1 is
9.
-9. Everybody with me? So now I have -9. What's the x value? -5. What's the y value? So I'm going to go to -5. 1, 2, 3, 4, 5. And then I'm going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can tell that these actually do what? They line up perfectly in a what? In a diagonal what? Line. What type of function did I tell you that was?
Linear.
Linear. What do I expect the graph to look like? A line, right? I expect it to be a line if I connected all the points. Did I find every single point that's on that line? No, I just found a few. I found 4 specifically. Could I have found more if I wanted? Yeah, I could have plugged in 1. I could have plugged in a half. I could have plugged in 3.5. I could have plugged in anything I want, right? But I just chose some. But I could have chose like 1 and -1, and those are easy, right? Most of the time you're going to choose an integer. You're not going to choose a fraction or a decimal because those are harder. Choose what's easiest to put in. Okay, so that's that one. Let's try this one. This one's quite a bit more difficult, and the graph is going to look a little weird. So I might not even graph this one, because I think you understand now that you're just going to find points. The reason is because what if I'm only finding this side of the U? Well, is there another side to this U? Yeah, it's over here. I just can't see it. So I might only be on one side of the U. I don't know where I'm going to be. But it's okay. I'm really just finding x and y values. And there's a reason we do this, and I'll get to that when we do the story problem part. Okay, so what am I going to substitute in? Tell me the 4 values I'm going to substitute in for this 4x in this equation.
-2.
-2. What else?
0.
0. What else?
2.
2. What else?
-5.
-5. Okay, this is what I want you to do. You can stop that for a minute.